Hello everyone, welcome to this lecture. In this lecture, I will try to start a playlist. The playlist will be about line integral. This is important for your math course in your university. This can be also beneficial for if you are trying admission in engineering in Bangladesh. Let's see what is line integral. First of all, we will learn the rule. We will learn the theory, and after that, we will do mathematics. So first of all, rule 1. What is rule 1? If we have an interval a to b is interval and a to b is interval and let's say f prime x is continuous in this interval. In this interval f prime x is continuous. Then the length of length of curve. We have to find the length of the curve, and the formula will be integration a to b and 1 plus ddx of y whole square root over, and we will have to integrate this term with respect to dx. This is our rule number 1. After that, suppose that here x was independent and y was dependent. In rule number 2, we can write if we have an interval a to c and b to d. These are 2 points. Then if we want to calculate the length of the curve, let's say if x is equal to f of y, then length of this length of this this length of this will be, this is another formula. The formula will be, look, here y is independent, so you have to integrate with respect to y. So let's write dy, and the interval of y will be c to d. So let's write c to d, and formula will look like same, 1 plus d dy of x whole square and root over. So this is our another rule. Our third rule will be rule 3. Our third rule will be, for this, let's say we have a parametric equation. Let's say f x is equal to f of t, and let's say y is equal to g of t. Now we have to, let's say we have 2 point t1 and t2. These are two parameters for 2 point, parameter for 2 point. Now we have to find out the length of the curve between t1 and t2. Therefore, between t1 and t2, length of the curve will become this. We have to write t1, we integrate from t1 to t2, and there will be a root over, and we will write dx over dt. Actually, this is ddt of x whole square plus dy over dt whole square. This is our rule number 3, and we have to integrate this with respect to dt. Okay, our rule 3 is done. Next, we have our last rule. This is rule 4. Rule 4, suppose that we have a, polar equation of x and y. Suppose that x is equal to r cos theta and our y is equal to r sine theta. X cos theta and r sine theta. X is equal to r cos theta and y is equal to r sine theta. Now, length of the curve, length of curve between suppose that we have two angles, theta 1 and theta 2. Between these two angles, we have to calculate the length of the curve, and this will be equal to theta 1, theta 2, and we'll have a root over r square plus dr over dt whole square, and we have to integrate this term with respect to d theta. So let's recap everything. Line integral. Suppose that we have why line integral is important. So suppose that we have a line, we have a curved line. Suppose this is a curved line. Let's say the equation uh, is equal to y is equal to 1 by x. Let's say. Then if this point and this point, if we know this point and this point, suppose that here x, the value of x is 1 and the value of ordinate is 1, and the value of x is 10 and the value of y is 1 over 10. Then if someone is try to try to calculate the length of a to b of this curve, he will need integration. He will need line integration. So line integration is very important. Line integration is very important. So we have so far 4 rules we have studied. The first rule was if we have f prime x is continuous in the interval a to b, then length of the curve will follow this equation, that integration a to b root over 1 plus ddx of y whole square, and we have to integrate with respect to x. In our second rule, if suppose that in the first rule this was x was independent, independent, and in the second rule our y was independent. So let's see, if we have y is independent, then we have to integrate with respect to y. So our formula will be just simplified. Is like the previous, that root over 1 plus dy of x whole square, and we have to put the limit of y. The value of y is c and the value of y is d. That's why I have written c and d. In our third rule, we have studied that if we have a parametric equation x is equal to f of t and y is equal to g of t, then we have to we can find out the length of the curve with this equation, that root over ddt of x whole square plus ddt of y whole square, and we have to integrate with respect to t. In the final rule, we have discussed that if we have a polar form of x and polar form of y, then our curve length will the equation of curve length will be look like this, that root over r square plus dd theta of r whole square, and we have to integrate with respect to theta. And why line integration is important? Line integration is important to calculate the length of the curve. So thanks for today. I hope you understand this video. Thank you.